All right, everybody, welcome once again to ESAB Welding and Cutting live stream. This is Weld-On. This is part of the ESAB University series. As I'm sure you are aware, myself and the internationally acclaimed Bob Moffat have been asked to jump on here every Thursday and basically go over some different welding tips and tricks that you guys asked for information on. We went ahead and reached out to you through social media on ESAB Welding and Cutting, as well as we went and I sent some stuff out on my personal page, and I think Bob did as well. We basically asked you guys for some information. So, first of all, oops, hold on. I got to add the little logo in the bottom right-hand corner. Boom! Wait, boom! That was over there. All right, so once again, I am in my shop, Big Tire Garage, by myself, running this whole live stream thing. So just a couple of things to talk about. Number one, if you see me looking over here occasionally, that's because I have a monitor over there that I'm looking at to make sure that I'm showing you the right picture. And if you have any questions or comments, make sure to jump on to the ESAB live stream and just dump them into the comment section, because what they are going to do is two things. Number one, there are some representatives from ESAB on there who will answer any questions that you have about any of the machines, any product questions, filler material, machines, setup, stuff like that. They're also going to be giving away to somebody who comments in the comment section today. They will go through the comment section. They will select one winner who will receive the new Savage welding hood. I don't have a Savage welding hood yet, so you'll have something that I don't have, and that says a lot right there. So put your comments in the comment section. And then on top of that, what we will do is both Bob and I have agreed that since it's kind of hard to do this, wear that, look over there, that probably the best thing to do would be to post a follow-up video. So if you have any questions, just go ahead and post them in the comment section. We will all go through the questions, look through them. If I see that a bunch that need to be answered, what I'll do is I'll create a follow-up video and we'll come back probably Saturday or Sunday. We'll repost something with that. So here we go. So today's lesson is going to be, basically I gave it a title. I got my lesson plan right here. Used to be a teacher, so I do that. So my lesson plan is common fabrication joints and machine setup as it relates to custom automotive fabrication. Now, last week, Bob showed you some typical MIG welding joints, and some of the comments that were asked about that probably applied to a little bit of what I'm going to show you today. So that was why I took some of the questions that popped up on my social media and created this lesson here today. So the first thing we want to talk about, as always, whenever we're talking about welding, is our PPE. So this one's going to be a little bit different. I know both myself and Bob covered it last time when we talked about personal protective equipment, but we're going to expand on it a little bit, and that's because of the environment that you would be working in if you were working in doing some custom automotive fabrication. So pretty much standard items still apply, of course. Safety glasses, you know, in the shop, always, all the time. I had a bunch of questions asked about these safety glasses. So these are, they're just a set of clear glasses. I got them from, hold on, I can get you a closer picture from that. There we go. So these are from, they're called heat wave glasses. They are made by a sunglass company, but they are ANSI certified, Z71 certified, or Z whatever it is. They're covered. I just use CSA. So they're certified safety glasses. The reason I like them is because they're just like the sunglasses I wear every day. When I wear them in the shop all day, kind of just forget that they're on there, which is pretty good. They come in these little side shields too that are removable, so if you don't want them on, you can just pop them off or pop them on. But anyway, so safety glasses, obviously in the shop, long sleeves, all that kind of stuff we covered last time. Welding helmet, you know, we are going to be welding, so that's a given. You got to have a welding helmet with you. But the one thing that I want to talk about that's going to be different is I want to show you 3 different kinds of gloves that I use a lot basically in my world of custom automotive fabrication. So the first thing I want to show you is a set. These are called fabricator gloves. And these fabricator gloves, they are, I love these. They're super comfortable and I wear them all the time. They're thin leather on the palm. And the back has some heat resistant stuff built into them. You don't want to wear a fabricator glove when you're doing a lot of welding, but they're great just to be wearing pretty much 90% of the time. So I'll wear those whenever I'm working with steel in the shop, whenever I am doing a little bit of tacking, maybe some short little MIG welds, and even some short TIG welds with them. The reason that you would want to take these gloves off and put on a set of preferably dedicated TIG welding gloves that you would use, because we're going to be doing some TIG welding today, TIG welding gloves has to do with what happens to the gloves as you wear them. So as you can see, these ones are pretty new. Oh, here's a pair that I've had for a while. There we go. So these ones are pretty new, but here's a pair that I've been wearing in the shop for a while. So you can see what happens to the palm of the glove is, as you're working in the shop, basically all the oils and any contaminants that are on the material that you're working with transfer onto these gloves. Now you may think, well, it's no big deal, I'll still TIG weld with these because they're lightweight, you know, they're thin, I can feel the filler rod. But the reason that I personally ditch them for a set of dedicated TIG gloves when I start TIG welding has to do with the filler rod. All those contaminants that are on the palm of that glove will get onto your filler rod. And in our world, in the world, especially in the world of off-road fabrication, we don't cover our welds. We let them show through. We want them to look cool. We may powder coat them or paint them, but we don't grind them down. So the last thing you want is to have any chance of any of that contamination transfer from your glove onto your filler material while you're welding. So that's why I have a set of lightweight fabrication gloves and a set of TIG welding gloves, and they're different. Also want to talk about actual MIG welding gloves. MIG welding gloves, they are obviously a lot heavier, they are thicker, they have more insulation on the back of them, and that is because while you are using that MIG gun, your hand is going to sometimes be choking up on the nozzle of that gun, and you want to protect your hand from the heat. MIG welding gloves obviously also gauntlet gloves, so it prevents your sleeve from peeking up and you get a bunch of slag on your arm. They have to be able to handle much more abuse than, say, a TIG welding glove because you have a lot of spatter and or sparks when you're MIG welding. I also want to talk a little bit about a welding jacket. Now, for here today, what we're doing, I'm not going to put on a welding jacket because I'm just showing you a couple little things on the bench. And whenever I am mocking stuff up or just working in the shop quickly, I wouldn't put on a welding jacket. But when I get to the point where I'm going to do a full weld out, so an example of that might be, you know, maybe I've got all the brackets tacked up onto an axle and it's on the stand and I'm about to finish weld it out. Or maybe I've got my cage all put into place and I'm going to start welding it out. That's when I'm going to completely change gears. I will go through, I'll grab my MIG welding gloves, I'll put on a MIG welding jacket, title up. Sometimes I don't even spike my hair, believe it or not. I'll leave the gel out of the hair, put on a weld beanie, and that's just because I'm going to be spending, you know, 8-9 hours welding. The jacket not only protects you, but it also ensures that you end up with a good quality and good looking weld because it never senses to, oh, one other thing I do, another little tip, is I wear earbuds or earplugs. And that goes into this next point. It never ceases to fail me whenever I'm welding. If I try to do a big, beautiful weld without a welding jacket on, I'll be running a nice bead and then I'll have that one little weld berry jump out and land right on my arm and then I jump. You know, of course I jumped. I just burned myself. I just hit, it was electricity fire that just landed on my arm. And then the weld has that one little imperfection in it. And that's all I'm going to look at for the rest of the time I ever go near that project. So that's why a welding jacket is nice. Earplugs and or earbuds. I like to put those in my ear because I have this awful habit of slag dropping inside my ear. And it just kind of, it just bubbles inside there. Freaks me out. Anyway, so that's our PPE basically for whenever we're working with specific to automotive type fabrication. Because I just wanted to make sure I show you those 3 different kinds of gloves and when you would use them. So now I want to talk about the gas and the wire. Bob touched on it last week. There were some questions about some wire and some gas, and I'm just going to talk about mainly what I use and what would be most commonly used in any type of automotive fabrication, and that's going to be a mix of 75-25, and that's a mix of argon and CO2. And then the wire that I use is actually an ESAB Aristorod 12.5. It's a really nice wire. If I'm looking to drop down a little bit cheaper in wire, maybe a Spool Arc 86, it's going to be a little bit more cost effective. But as I said before, you know, when I'm working, if I'm building something, I want my welds to look the best that they can look. So the way I look at it is my welding wire is, to me, the same as automotive paint is to a painter. You know, I want the best wire coming out of my machine so I can have the best weld possible when it's all said and done. So that's what I use. Usually an ER70S-6. Bob covered that last time, so that's a pretty standard welding wire that we all use. Now, I also want to talk about consumables. So this more speaks to you guys who are, maybe you are an automotive fabricator or customizer, or maybe you work in your shop at home. If you talked to a welder and found out how often they change the consumables in their MIG welder, it would honestly shock you. And by consumables, I'm referring to both the nozzle and the tip, contact tip in the machine. So the nozzle and the contact tip, this contact tip is incredibly important. The reason it's so important is the contact tip is the last point of contact between the power supply in the MIG welder and the workpiece that you are welding. And they do wear down. You obviously want to make sure you're running the correct size contact tip. So if you're running an 030 or 8mm wire, you're going to run an 030 contact tip in your machine. If you are at home working in your own shop and you run out of, let's say your machine has 035 wire and you run out of wire, or you've welded up the tip and your buddy says, oh, just go to the next size up tip, it'll be fine. Your buddy's lying to you. It's not going to be fine. It's going to be a bad day, and you're going to be grinding a lot of welds off, because what happens is you'll end up with intermittent contact between the welding wire and the contact tip, and you'll end up with some welds that don't look good and, more importantly, aren't as strong as they need to be. So what I like to do is I'll keep an eye on my contact tip and keep an eye on my nozzle. The one thing that can happen with the nozzle is it'll get packed up inside here with some slag, because it'll obviously feed back in. You can get nozzle gel or some anti-spatter spray to help prevent that. But what I tend to do is whenever I'm about to do a full weld out, as I mentioned before, whether that's a chassis, a cage, or maybe a bunch of brackets on an axle, I'll go through my MIG machine and I'll replace the contact tip, put a fresh nozzle on, as well as I'll also put a new screen on my welding mask. I keep a lot of these around. They just fit the front of the helmet. Pretty much any welding mask out there is going to have some sort of protective screen in front of the auto darkening portion of the lens. I'll put a new one of those in my helmet and just make sure everything's fresh and new. That way you'll end up with a good, high quality weld whenever you want to run. All right, so we've covered consumables, wire, gas, PPE. Let's jump right into probably the most common joint that is going to happen in our world. And when I say automotive fabrication, I mean anything from, maybe you're building an off-road rig like I do, maybe you got a Jeep or a rock crawler or a tube buggy, or maybe you're building a mini truck or a chopper or a hot rod or a street rod or a muscle car, anything. Most of the time, the biggest issue that we're going to see is we're going to be welding material that's similar in nature but different in thickness. So what I mean by that is this. So let me get this set up right where you can see it here. There we go. And we're going to merge these two over. So this is an actual piece of axle housing off of one of my projects. It's a piece of 1/4-inch wall steel. I'm not sure if it's chromoly. I don't believe it is. I think it's just mild steel. But what it is it's a piece of 1/4-inch wall, thick axle tube. And believe it or not, in my world, this is actually a thin axle tube. A lot of the time, what you'll see is we'll have 3/8 to 1/2-inch wall axle tubes just for strength. But 1/4, that's a pretty standard. So if you were ordering up a rear axle for a fabricated 9-inch rear axle for one of your projects, it could have a 1/4-inch wall or a 3/8-inch wall. The reason this has a 1/4-inch wall is because it went into an Ultra 4 pre-runner type car, and so this 1/4-inch wall was there to give us enough strength, but not a whole bunch of weight. So the reason I'm focusing on the thickness of this axle tube is because when it comes time to add brackets to this axle tube, that's when we come into the biggest problem that we're going to see. And that is that 9 times out of 10, the brackets that we use to mount our suspension components are a different thickness than the tube that we are welding it to. So in this case, it's not a huge difference. What I have is a 1/4 inch wall axle tube and a 3/16 inch P&O plate steel tab for this 1.25 inch heim joint. So you can see that right there, 1.25 inch heim joint. So this is basically a pretty common issue that you're going to come up to. You basically have thick steel welding onto thinner material. And so the question is, how do you set the machine, and how do you work the molten puddle? So first thing I want to talk about is where to tack the bracket. So whenever you're putting a tab onto an axle, I don't have an extra one, so I'll just blow this apart. Whenever you're putting a tab onto your project of any type, there are multiple places where you can tack it. So if we were to take a quick look here and turn this the right way so you can see it, let's say this tab's going to go right here. This tab, there we go. So this tab is going to go right about here. So most of the time, 9 times out of 10, what's going to happen is you're going to drop the tab into place, grab the MIG gun, because you've only got 2 hands and you're trying to hold this, you're trying to hold that, and you're just going to stick it somewhere in there, pull the trigger, and tack it into place. Well, the reason that you don't want to do that is twofold. Number one, if I have a tack in the middle of this tab, and then I go to weld it out, chances are when I get to that tack, my weld is going to have to climb up over that tack. And it's going to just diminish the quality of the weld. Yes, it could also technically be weak right there, but it's more just the fact that it's going to diminish the appearance of the weld at that point. The other issue is when you tack it, what's going to happen is it's going to pull the tab. So whatever side you apply heat to, it's far away. So if I apply heat to this side of the tab, what wants to happen is the tab wants to pull this way. Same thing if I weld onto this side of the tab, it's going to pull the tab. If I weld onto this side, it's going to pull the tab this way. So for my personal preference, whenever I'm working on a project like this, no matter what kind of tab it goes down, whether it's a link tab like this, or an engine mount tab, or even just tab to pull to limit strap on, or even just a tiny little tab that's going to be used to hold an antenna or a radio, I tack it always, 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 always. I'll show you. Sit up there. I am going to completely assemble whatever I want to tack, whatever I'm going to be building, and I am going to tack it right at the end. So I'm going to tack it here, I'm going to tack it here, and then I'll go underneath and I will tack it at the back side on the other side. That is going to minimize heat distortion. It's going to prevent this tab from trying to pull this way or that way. And the best part is, because my tack is here and here, as I weld this joint and perform what's called a corner wrap, we'll talk about that a little bit later, as I perform a corner wrap, it's just simply going to bury that tack inside that joint, and then you're not going to see it. It still does its job because it holds the tabs in place as you get ready to weld, but there's no chance that that suspension piece is going to move around on you while you're working. So that's where to tack it. Now let's talk about how to weld it. So it's tacked and we want to weld it. So let's just do this. Here's what we'll do. We'll tack it. We'll tack it in place. Let me turn the machine on here. Make sure to turn the gas on. That's important. Okay. So as always, just like last time, I'm using my Rebel EMP 205 AC/DC. You don't have to use because we're actually only not doing aluminum today. I could have thrown the Rebel 215 up there, but I already had it all set up from last week. So that's what we're using. All right. So I'm in SMIG mode here. Trying to get it to talk to itself. Oops, I may have to restart it. It's not happy. Okay, there we go. So, as I said before, just to reiterate, we are going to have somebody on the Facebook stream who is going to be answering any questions that you guys have about products or filler material and like that. And also, if you comment, ask a question, the ESAB is going to be giving away a Savage helmet to somebody who comments inside the video today. So make sure to drop your comments, questions, and any questions that are in there, I will go through and make a follow-up video later on. So if I don't get to your question near the end, if I don't see it, don't feel bad. I'll make a little follow-up video later on. So always coffee before welding. That's the rule. All right, so, okay, so I've got since I'm tacking, I'll just wear these. Got little peepers, got my thing. This thing is ready to go. Okay, so what I'm gonna do is I'm gonna tack it and I'm gonna kick this over. We'll see if this one can even keep up. I don't know if this camera can keep up to this, but we'll find out. Okay. Thing on here. Okay, so what we basically have here as an example, this is an 1.25" heim joint that you would see on, heavy-duty rock crawler or off-road rig, some 3/16 tabs, and this would be pretty standard lower suspension link setup going into this axle. So where I want to tack it is just like I told you before. I'm going to come in here and it's going to drop a little tack right in here. Oops, didn't put my glasses on. There we go. I drop a little tack right at the end here. Okay, and then one on this one. And I'm pulling the tab towards the axle to keep it from walking out. And then, as I said before, I would roll it over and immediately tack it on the backside. Okay. All right. So, one thing I noticed last time, because I'm sitting right here by this fan, is I kept yelling at you. So I'm going to turn this machine off. There we go. Turn this machine off whenever I'm talking. So we now have our, right camera's up. We now have our tabs tacked on to our axle housing. Now, I don't want to get into a whole big long conversation about, then you would set up all the other tabs. And this isn't a lesson on how to build a 4-link. This is just covering dissimilar thicknesses of material. So we now have 3/16 tabs tacked onto a 1/4" thick piece of axle housing. So now the question is, where do I set the machine in order to get the best weld? The way that I like to do it is I always go to the thickest material. So in this case, unless it's a huge jump. So even if this was 3/8, I would probably still set the machine maybe hot for a 1/4". I would look at the parameters for a 1/4", 3/8, and maybe split the difference. But on this particular difference, because it's so little, it's just an 1/8 of an inch difference with 3/16 and 1/4. I would set the machine up 100% for the 1/4", because I think it's more important when you're doing this that you have good heat penetration into the thicker material. But because of that, you need to pay attention to your torch position and your torch angle. Now, if you jump online and look on YouTube, and you can find some great information out there from people who will teach you very, very well how to use a MIG welder. And then there's some misinformation out there. So the first thing I want to talk about is cover misinformation. Welding, you'll hear people often say, oh, you just make cursive E's, just cursive E's, or C's, little C's, little... Well, if welding was honestly that easy, we'd all be great at it, because we learned how to write cursive E's in middle school. Well, elementary school, I guess. So you learn how to write a cursive E at a very young age. And I have the worst penmanship, but I got good E's. So you should be a great welder. That's not what the little E is doing. What you're doing when you're welding, let me kick this over here. What we're doing while we are welding is we are moving the torch to manipulate the weld puddle as we are welding. So the cursive E move is like, if I just said, oh, just do cursive E's, you may think, oh, I'm just going to do this. Go do, or little C's, just little C's, back and forth, back and forth, back and forth. What I need to do, what I'm actually doing when I'm making those shapes, whether you are paying attention to it or not, is what I'm actually doing is I'm manipulating the weld puddle by changing the position of the electrode, which is the little wire that sticks out of the MIG gun, and the head of the torch. So when that wire comes out right there, if I keep it straight like this, then my molten puddle will be right in front of the wire. If I twist it, the molten puddle should move around a little bit. That is that movement that you are doing. So in essence, yes, cursive E's is a way to describe what we're doing, but what we're actually going to do is we're manipulating the molten puddle. And it becomes incredibly important when welding two different thicknesses of material like this, because what I want to do is I want to make sure that I am spending enough time with the molten puddle on the 1/4 inch, but also allowing the molten puddle to walk up onto this 3/16 inch plate and weld it in as well. If I just did little E's or just buried the torch in there and just moved it all the way down, one of two things is going to happen. Number one, I'm going to have either insufficient penetration into the 1/4 inch because the puddle is not going to be pushed into this 1/4 inch tube, or I'm going to have a whole bunch of penetration into the 1/4 inch, and I'm going to have a whole bunch of undercut into the 3/16, because what's going to happen is the amount of heat that you're generating into that 1/4 inch is going to transmit up into that 3/16. So what will happen is it'll actually undercut, which is not good. Undercut is when you can, like, the metal's flat and then there's a little dip. Okay, the weld is actually cut under the metal. It's weakened the metal because you've actually eaten some of it away. So what you want is that fine line right between the two, right? You want good penetration into the 1/4. You want good penetration into, in this case, 3/16 inch steel. And so the movement for something like this particular, see if I can set this up so you can see it a little bit better. There, we got a little bit better light on that one. Okay. So the movement for this particular joint would be something like this. You'd basically go, get my big fat hand out of the way. I'm going to come, you know what I'm going to do? I'm going to try, here we go. There we go. I'll come this way. It's a little bit tricky, but it's all right. So what you would do is you would start with the nozzle and the gun and the electrode basically pushing into the 1/4. And then what you would do is you would bring the puddle, or push or pull, really the same application applies here. So you're basically pushing the puddle along the 1/4, and then you are pulling it up onto the edge of the 3/16, paying attention to make sure that it does not undercut into that 3/16, and then immediately coming back down onto the 1/4, pushing up a little more, up shortly onto the 3/16, back down, up, over, down, up, over, down. And then the most important thing is what you do is you'd call wrap the corner. So on a joint like this, you would come up around the top, keep welding, same process, come around the top, and then you would come onto the inside and you would weld as far as you could until you either hit an obstruction or were just out of position. But that's what's called wrapping the corner on these tabs. That is what's going to give you the best weld and the best strength. And to give you an example of that, watch this. It's like the cooking shows. It's like the cooking shows. Are you ready? Hold on. It's going to look like that. So it's going to look like this. So as you can maybe if I can get it to focus. Come on, focus, little camera. As you can see, what I have here, it's hard to focus. It's trying to focus. It's doing its best. Come on, little camera, focus. Focus. So as you can see, what I've got is I basically have a weld here that's on. It's got good heat penetration into the 1/4, and it hasn't undercut any of the 3/16. You can actually feel it. And there's no undercut at all into that 3/16. And even on the back side, you can see it has good heat penetration into 3/16 as well. So that is, hold on, I gotta get my thing. Boom, boom. There we go. So that's the first step in that particular type of joint. That's the first step in welding, setting up for a good quality weld on a set of tabs that maybe you've welded on to your axle housing. I also want to talk a little bit about the distortion that those tabs are going to see while we're working on them. So we're at 30 minutes, but we're going to keep going because I've made that decision that we can do that. Let me just jump over here, double check, see if everything's good over here. Okay. Ooh, good. Lots of questions. Great. As I said before, it's kind of hard for me to do this, talk to you, look at these, run these cameras, and answer questions. So just post those questions up in there. We'll go through them all. Also, if you have an idea for what we should do next week or the week after that, let me know. We'll keep going on these. So just keep that in the process. So keep feeding those in there. You can win a Savage hood, all that kind of stuff, and we'll answer your questions. So back to the welding joint. So we talked about machine setup. I would set this joint up for the thicker of the two materials, so in this case, 1/4 inch. Concentrate on that weld puddle position, ensuring that the weld puddle stays onto the thicker material and is just drawn up onto the thinner material, focusing on making sure I don't get any undercut. And that is why really paying attention to that weld puddle is so important, and it's not just about making little shapes with the torch. So we talked about that. Also, this particular joint setup here, it's pretty particular for this particular project because this is a 1/4 inch and 1/4 heim with these bolts through here. So in my world, I have scrap heims, scrap tabs, scrap everything. So this joint, I would have no problem welding this up with this heim in here because I know this heim is going in the trash anyway. But I know that's not the case for you guys at home. You may not have that ability to do that because maybe you're building your project. You don't want to run out and buy a whole bunch of extra heims. You want to ensure a couple of things. So number one, when you are, I'm going to kick over to the other, I'm going to try and tilt this up a little bit. There we go. Reach as far. So there we go. So, mouse keeps moving on me. There we go. So, when you weld this, as I said before, is this tab is going to move. And there's nothing you can do about that. As you weld this metal, if you weld on this outside, it's going to try to pull this way. If you start on, you can start on the inside and weld around that way. If you do that, it's going to pull this way. Either way, so there's two schools of thought. Number one, you have one option: weld the, leave the joint in there, weld the inside first, and then it will pull tight, and then weld the outside. It will pull to the outside. What I like to do is two things: either one, make a spacer that will fit in here that you can just leave in there while you weld. So that can be anything, a piece of scrap tubing, anything, as long as it is the same distance. You can go ahead and leave that piece of tube in there. Put the bolt back in. So you'd put the bolt back through the holes, put your piece of scrap tubing in there, and just keep it tight, weld it, and then let it cool, and then it should go back to, you should be able to pull that piece of tube out. You may want to ensure, some people, you'll add a washer, make the piece of tubing just a little bit bigger, and that way that will help give you space to slide the heim back in. But there is another thing that you can do, which actually not only will help prevent the tabs from moving, but it also can make the entire package a little bit stronger. And that is a little filler piece. So let's come back over here. Come on. There we go. So if this was a suspension piece that I was going to put on my truck, I would ensure that I added some type of filler piece to either the top or the bottom. Move this a little bit closer so you can see it. So I would make a filler plate that goes across the top or the bottom. And there's a couple things you need to pay attention to here. This filler plate, make sure that it doesn't interfere with the heim joint as it's in place. You want to make it as tall as you can, but you don't want to get to the point where as the suspension cycles, it hits the heim, hits the actual filler plate. Pull the filler plate back and make it so there's a nice tight fit up between it and the axle tube. And make sure that when you make it, see if you can see this. When you make the filler plate, make sure that you have a step. Don't make it so it's flush like this. You want to make sure that you have a little bit of an offset. So when you weld in here, you'll get good penetration into both the tab and the filler plate. And also, another little tip, add a hole to it, or sometimes I'll add a little half moon onto this bottom section. That way any dirt or that, there's a greater chance it's going to get out. You don't want to make like just a little pocket for the dirt and mud to sit in, or even just road grime and water. So what I would do is I would put this in place. If you tack welded it at the top and the bottom and then welded out your tab, the chances of this tab distorting while you were putting it together is obviously a lot less. Still a good idea to throw a spacer in there or an old heim joint if you have it, because what that will do is it will just keep those tabs from moving around. So that's that little joint right there, and that's that little setup right there. Another joint that I want to talk about has to do with how we would make this even stronger. So I showed you guys how to basically add this little tab to the top side here to make it strong. And that's going to make the assembly strong, but there's a way to make the entire package even stronger. And to do that, you need to understand your loads. And the reason I want to talk about that is because I'm sure there's probably some people out there right now who are saying, well, that's a lot of work to deal with, you know, dissimilar thicknesses of material. Why not just go ahead and, if this is 1/4 inch, make your tabs at a 1/4 inch. If this is 3/8, make your tabs at a 3/8, which is one school of thought. But there's two problems with that. Number one, if you're dealing with a tab to hold a suspension mount on, 3/8 plate, it's pretty thick. That opens up a whole other can of worms, because we'd want to prep the surface a little bit different if we're welding 3/8. We definitely want to come up with some type of bevel in there to make sure that we had good penetration into that tab. But more importantly, in the world of automotive fabrication, it basically boils down to weight. And weight can mean two different things depending on what you're building. If I'm building a drag car or a land speed car or even just a hot rod, I don't want to add a whole bunch of weight to it, because the more weight I put on it, that means the slower it goes. In an off-road vehicle, we don't want to add a whole bunch of weight to this axle, because that just adds more heft to the piece of the suspension that we are trying to control when we drive incredibly fast over bumpy roads, big whoops, and big rocks. You know, it doesn't sound like a lot, but if you added up all the tabs and brackets and everything on an axle and then made them twice as thick, you know, that axle could go from, you know, 700 pounds with tires and wheels on it up to 900 pounds. And that's a huge difference. That makes a big difference in how the shocks react, how the suspension reacts, so that's why we don't do that. But we can make this stronger, even more stronger, and it has to do with understanding how the loads show up inside your suspension. So if I come down here, I want to show you this. Come on, get up there. There we go. There's that. So this is a picture of the suspension underneath one of my trucks. This is what's basically called a Ultra 4 4400 luxury pre-runner. So you can see it's got a whole bunch of shocks on the back. It's got a 3-tube bypass and a 12-inch coil carrier. This thing has just over 17 inches of suspension travel, and it's on a trailing arm setup. It's a 500 horsepower. Basically, it's like a King of the Hammers car, but it's a Jeep that you can drive on the street every single day. But the reason I'm showing you this is I want to show you, you can see that little sort of very poorly hand-drawn arrow right there. I'm not an artist. Don't judge me for it. But that's showing you the actual load that happens inside a suspension when you build a car. The load is happening front to back, not so much up and down or side to side. There's a little bit of side load, but if you've built your suspension correctly, there should be minimal side load on that. So the load inside your suspension as it moves around is basically fore and aft inside the vehicle, so front to back. And that means that on a suspension system like this that has a heim joint, I'm going to come over here, come up over here, get this other camera ready. There we go. On a suspension system like this that has this heim joint in it, as you can see, we put the bolt through here. So that means that as this thing is driving down the road, this bolt is under an incredible amount of stress. It's back and forth, back and forth, back and forth. Oh, I moved this forward. Sorry. Basically back and forth. This is the failure point in this suspension system if it's built correctly, is this bolt. That's why you'll see us run either a grade 8 bolt, which is these little gold ones. They're not just gold, they actually have the markings on the head. The head tell you what grade it is. or even F9 bolt, which is higher than grade 8, but that's usually reserved for $250,000 trophy trucks. But grade 8 bolt is probably the best one to run. That's what we all run in them. And you'll see us run larger bolts. This is a 5/8 bolt. Usually suspension is 5/8 to 3/4 of an inch thick. But we can make this bracket stronger just by taking advantage of how the steel is going to react to a situation like this. So we know that the load is back and forth. So we know that the bolt's strong, it's hardened steel. We know that the heim joint is strong, it's hardened steel. We know that these stainless steel misalignment spacers are hardened steel. So our one area that's going to become the weak point is basically this hole. So this hole is going to be the problem. If we are going to see any damage in this particular system, in this particular package, it's going to be the hole that this bolt goes through is under an incredible amount of stress. So what can happen is the hole can elongate. If the hole elongates, then the bolt starts to slide back and forth. If the bolt starts to slide back and forth, that puts undue load onto the shank of the bolt. And then what happens is the bolt fails. And when the bolt fails, it's not a good day to be in the driver's seat of the car. So what we create is what's called a shear plate or a weld washer. So shear plate or weld washer simply looks like this. This is just another small little piece of steel. You can actually buy them or build them. I cut this on the plasma table this morning. If I was going to recut it, I may move this hole just up a little bit. But I make them specific to each project that I'm working on, so I just had this file in there, so I just grabbed it and made it. So the way that this works is all you do is when you're building your suspension, you'd simply put your shear plate in place right here. And then you tighten this bolt down. Oops, tighten this bolt down, nut down rather I should say. Put it into a position that looks good. I can't see in the picture over there. There we go. There we go. Set it in a position that looks good. And we would then weld this into place. Now, when I say weld this into place, this would be another point. This would honestly be where I would completely change the process in which I was welding that. I wouldn't necessarily MIG weld that because the forces on that, it's number one, it's an incredibly small piece of steel. The forces on that, as we talked about, are fore and aft in the suspension system. It's pulling and pushing. It's there just to increase basically the overall thickness of the bolt hole at this point in the suspension. So what I would do is I would TIG weld that into place, and I would probably just run a fusion weld around the whole thing because all I'm trying to do is just basically keep that in place. I just need to keep one of those on either side, and that is going to strengthen up this entire package. So if I have, there we go, let's kick this back over to our little camera. So what I have here is a suspension link mount point out of 3/16 steel. I have a brace on the bottom or the top or both, depending if you can make it work in your suspension system. And I now have a weld washer or shear plate added to the system. This is incredibly strong, and more importantly, we've added strength in all the right places. We've set our welder up correctly to weld it so we know it's strong and we know the weld is good. And most importantly, we've added the minimal amount of weight that we needed to add for this particular setup in order for it to work correctly. So that covers that one single popular joint that you're going to see in a suspension system. This went way longer than I thought I did. I'm sorry, but that's just how it works. Sometimes I talk a lot. So basically, that's going to cover a very common joint that we're going to see in our automotive fabrication, welding thick to thin. Hopefully, I covered a lot of the questions that might come up, and I hope you guys enjoyed that. Now, I do have another joint we could talk about if you wanted to. I'm just looking. I can either stop or we can keep going. It's up to you guys. So Philip Wells, he said, good idea. I need to put a weld washer on my shock mounts. Weld washers are great. You can actually buy them pre-laser cut by most people. Most fab shops will sell them, or just like online retailers have them. And you can just buy those weld washers, and they'll just ship them to them, get them, and add them. I put them everywhere I can. They're great to have. So, all right, Chris Jagger said go for it. So we're going for it. All right, so now I got to get back and back to my little screen here. Okay, so sorry about that. I had to look over there. I apologize. So that covers that one joint. So now I'm going to move this out of the way, and this kind of goes hand in hand with this particular setup. So another popular joint that we're going to be working on, we're going to be talking about, is a control arm mount. So this is, as I said before, a very typical suspension package that you're going to see in my world. Get rid of this. Which is an 1.25 inch heim with a 5/8 or 3/4 inch through bolt and some type of tubing adapter. Now, you usually buy it like this. Let me kick my little thing over. They are usually sold as a package like this. This is called a tube adapter. This is a jam nut. This is for adjusting the suspension. There'll usually be some type of misalignment spacers. These are high misalignment spacers because this is an off-road car. You can see that that's how much the axle can move one way or the other. This is, as I've said before, is a heim joint I've had laying around for a little while. So now, depending on what you're building, you'll have these heim joints in many different sizes. If we were talking about a street car or a drag car, you would probably have a 3/4 heim. And what we're referring to in that size is the size of the shank, is this bottom part. So this is an 1.25 inch thread down here. If you were building a street car, you would probably have a 3/4 inch, which is just overall smaller, still incredibly strong. These have just become the norm in our world just because of the abuse that we put the off-road cars through. So, but what I want to talk about is this little part right here. So this is your misalignment, or sorry, not your misalignment. This is your tube adapter. So when you buy your heim joints for your project, you're probably going to have some type of tube adapter that comes with it. The tube adapter is designed to basically be welded into a piece of thick-walled DOM tubing in order for the heim joint to be attached. Now, as you can see, if I can get over there, click. So this would be a pretty typical piece of suspension tubing that I would use in one of my projects. This is, I believe, might be 2-inch quarter wall, I think is what it is. I'm just trying to get that to stay over there. So this is a 2-inch quarter wall. That would be a pretty typical suspension link. It's incredibly strong because we drag these over rocks a lot. Now, you get your misalignment spacer, and all it does is pop into the end of the tube. Now, a lot of people would take this and immediately just weld that up. I mean, look, it's perfect. You could just stick your MIG gun right in there, or your TIG torch, and you could just weld that up and everything would be fine. But there's actually a better way to deal with it, and it has to do with, this is pretty common. This will sort of apply to anybody who is used to working as a welder, and that has to do with beveling your tubing. So on the other end of this tube, I've prepped it the correct way. So on the other end of this tube, you can see what I actually did is I took a grinder and I created a bevel on the end of this tube. So on the end of this tube, I've now made an angle that's similar to the angle that's on the tube adapter, and I would put it in here and I would weld it. But I would not MIG weld this. I would TIG weld this. And I would TIG weld this for a couple different reasons. Some people like to also drill this tube and put what's called a plug weld in. So they put this tube in here, they drill this, they put a plug weld in. If you do that, I would say check the thickness of your tube adapter. You can see how thin this one is. So my fear with doing a plug weld on a tube adapter that is this thin is you have a greater chance of completely distorting the threads inside that tube adapter to the point where even a tap isn't going to be able to save those threads, and you actually could be creating a weak point in the threads. So if it's a really, really thin walled tube adapter where the threads are, I'm not a big fan of plug welding it. If it's thick, like really thick there, like thick enough that you could put heat to it and it's not going to distort, then a plug weld all day long. But what I would do in a case like this is I would do a multi-pass TIG weld on this particular joint. What I would do is I would grab my TIG torch, which I happen to have over here, Boop. Take a torch, and I would get right in here, and I would perform a really, really good root weld. So the root weld would basically run all the way around that joint, connecting the tube adapter to the piece of tubing. Then, after it cools, I would come back and do 2 covers. I would weld this tube down into the root. That would be the first cover. So I'd cover it that way. Then I'd let it cool, and then I'd come back and I would weld this tube adapter into the root as well. So I'd basically be working the torch, basically pulling the tube adapter down. That would be the torch motion I would use, and I would add filler when I brought it down into the root. So I'd be like heating it up here and then adding the filler down inside like that. See if we can, here, you know what, I can get you closer, hold on. Boop, ba-doop, ba-doo. We did this last time. I hope you enjoyed your ride last time. Here we go. So, come on. There we go. See if it'll focus on that. So, what I would be doing is I would put a root pass, which would be right down inside here. So my root would basically be connecting the tube to the tube adapter. Then I would come back and do two cover passes. One pass connecting the tube down into the root, and then another pass connecting the tube adapter down into the root as well. And then if I wanted to get really fancy, you could do like a weave across both cover passes, putting a cap on it to make it look really pretty. You could even switch out to a different filler material if you wanted to at that point. That's getting a little crazy, to be honest with you, if you want to do that. But you could. The reason that I think that's a better way to weld those tube adapters in is twofold. Number one, it's going to allow you to really take control of the heat input that you put into that tube adapter, less chance of the threads distorting. It also allows you to ensure that that tube adapter is fully welded into that piece of 1/4 inch tube, because if you just tried to MIG weld that, you really would have to crank the machine up to get good penetration even into the end of that. You can MIG weld it, but just be ready for a lot of distortion into that tube adapter, because the jump between the 1/4 inch to the thickness of the wall where the threads are is really, really high. So you're going to put a lot of heat in that to get a good weld. By doing multiple passes and the cover pass and stacking them on top, you're going to end up with a much stronger joint, and allows you to also ensure as you're welding it that you end up with a really, really good weld at that joint. One other thing I want to talk about is, as I said before, I understand that a lot of you guys, you might not have a bunch of spare joints laying around your shop, and so maybe you don't have the ability to, you know, just have it stay in there while you weld. This is your best friend right here. Whoop. The old blue painter's tape. So this tape, you can pick it up at the dollar store or anywhere you want. If you go into any high-end fab shops, they will use this stuff like it's going out of style, because you can get spark paper and stuff like that that prevents the sparks from hitting the joints and the shocks and all that kind of stuff. It's incredibly expensive, and realistically, put a bunch of layers of this blue painter's tape on it, it's going to do almost the exact same thing. So if this was my only joint like this, what I would do before I even tack weld the tabs on, I would cover this bolted into place, and I would cover especially any of the machine surfaces with the blue painter's tape, because we don't just want it to stay looking pretty. We do, they're expensive, but also if you look at these joints, there's actually a little bushing inside of it, and you don't want the bushing, you don't want a weld berry to get jammed up on the spherical ball that's inside the bushing. So we'll try to get this in the right spot. You don't want a weld berry or any type of spatter to get onto this machine surface ball, because there's a bushing inside of here. And as this works back and forth, as the suspension moves, what can happen is if you have a little weld berry on there, it can basically wipe out the liner of your rod end a little bit premature and cause some damage. Most important when you're dealing with shocks. I see it all the time. Guys will like throw a set of $1,000 shocks on there and they'll just like have it completely expanded and they'll be tacking tabs on at the bottom. It really is a good idea. You want to, whenever you're working with a shock, you want that sucker compressed all the way so that shock shaft is up inside the shock, because any weld spatter, the smallest little piece of weld spatter that gets on that shock shaft, it's going to wipe the seal out of that shock, no questions asked. Or wrap them in a whole bunch of blue tape, and what happens is when the weld berry hits the spatter, hits the blue tape, it cools off and just sort of burns into the tape. You'll go through a lot of this, but it's definitely worth having around. So there you go, guys. I didn't get to everything this week because I still have a couple of things that I wanted to talk about. Let me just see here. Oh, one other thing. If you are doing any type of heim joint welding, go ahead and just get the tap. So whatever size your heim joint is, whether it's 1.25 inches or 3/4 of an inch, before you start that project, go out, get the correct tap for it. After the joint is cooled down, it's always good practice just to run a tap through that tube adapter before you start to screw the heim joint in, because what happens is if you have any distortion in the threads, you'll get the heim joint 3/4 of the way in, and then it basically will be in there for the rest of its life, because it will basically gall up on the threads on the way in. You'll never be able to get it back out, and you'll be basically throwing out the control arm, replacing the joint, replacing the tube adapter, and replacing the piece of steel, all for the cost of a tap. Even these big 1.25 inch taps, they're $100, but if you add up the price of this joint, this piece of tubing, we're probably at $100 right there. So get yourself the tap and plan for that. So that was that, and we don't really have time to get into that because it's like almost 1 o'clock. I don't want to be here all day. So there you go, guys. So there's a couple tips and tricks on how to deal with some very specific joints as they relate to automotive fabrication or custom automotive fabrication. Once again, if you have any questions at all, be sure to leave them in the comment section. I'll be going through all the questions and doing a follow-up video on some of the more common ones. And then also, if you have any ideas or any requests that you want to see next time, we can talk about that. One thing that I was going to talk about that we might be able to talk about next time, if you want to, I was going to talk about how to deal with stainless exhaust. So that's one that I was thinking about doing. I don't have time. We'll be here for another hour if I get into stainless exhaust. But if you want to see stainless exhaust, leave it in the comments section, and then we'll do it next time, because it's a whole bunch of TIG welding and it's lots of fun. So once again, thank you so much for joining me here on the ESAB Welding and Cutting Facebook page. I'm Ian Johnson. We're here in the Big Tire Garage celebrating National Welding Month. Myself and the internationally acclaimed Bob Moffat, bringing you tips and tricks for you guys to practice. So I hope you guys are doing okay out there, and if you are at home or out of school or have some downtime, this is the perfect time to get out in your shop, break out the welder, practice, grab some coupons, practice some stuff. And even if you don't have access to a welder, here is one little piece of oh, I spilled my coffee. Here is something you can practice if you are a welding student and you don't have access to a welder. Go ahead and do two things. Number one, practice feeding filler material through both hands. So practice that, because that is a skill that the more you practice, the more muscle memory you will have, and it will make you better at it. And also, go ahead and practice the infamous walking the cup basically down the piece of paper. So I'm sure if you don't have access to a TIG torch, this will be a little bit difficult, but basically what you want to do is practice moving the cup down the piece of paper with the basic zigzag pattern drawn on it. If you don't know what I'm talking about, just search that. But those are two things that you can practice even if you don't have access to a welder. I hope everyone enjoyed our lesson today. Thank you so much for joining me, and we will see you next time. Next week is Bob Moffat, internationally acclaimed Bob Moffat. All right, guys, once again, I'm out. Just for fun, I'm going to do this for the outro.